Hi everyone, and congratulations on making it through section 4A, or subsection A, of this tutorial series. And in this video, we're just going to go over our material, our Geisner wave material function, and our tessellation function. I'm going to open up the tessellation function from our main sort of water material. So in our water material, what we're doing, oh, by the way, while we're here, if I didn't show it to you in the other videos, you can kind of see the different color moving across with one of the waves there. So the reason why I'm pointing that out is if you unplug the tessellation multiplier, it's easier to see. But that's what's happening here, is we're moving between three colors based on camera location for two of them, so our near and far, and on the movement of this light texture here across this material here. So if you look at right across these two, you can see that light movement there. We're just clamping between 0 and 1, and that is our crest color. So we're moving between three colors by panning two textures across each other and by using our Fresnel, so the angle at which we're looking at, to create two colors. It's not really near and far, actually. That is a misnomer. It's the steepness of the angles, how near versus how far in height we are from the water. So not distance near and far. So that is a bit of a misguiding thing there. We set up some base parameters for our metallic, specular, and roughness functions. For opacity, we use a mix of depth fade, which, by the way, if you're having issues and you do want to adjust how that looks there, where it's intersecting, it's your depth fade that's going to play a role. But we are using our depth fade to account, our depth fade and Fresnel to account for our opacity. So that goes into our opacity. We also use our depth fade for our refraction. Speaking of which, remember that it's surface translucent, default lit, two-sided, surface translucency volume, use static lighting, flat tessellation with no crack free but adaptive up to 20, pixel for refraction, normal offset. If you do not have this on, and you use my favorite spot to stand, you're going to get some weird lines where it's clear on part of the line and really blurry on the other. Make sure your pixel normal offset is on. All right. Outside of that, then we have our normal map, which again, we are moving our normal map. They are being panned to give us this sense of the waters moving. And we're panning at two different speeds on each of these. Now, one of them does match the speed at which we're panning up here, but does not, or sorry, up here, it's actually the second one, but the top ones don't match each other, so they're a little bit different. You can match them to see what they're like, and we combine our normals into how we lerp between on our Fresnel, or how we lerp between our colors using our Fresnel. We also use our wave normals and these fake pseudo wave normals to blend our normal space to give us more complex normals. We then use the Geisner wave formula 4 times added together to create 4 different sets of waves that we can see on the map and to make it more realistic. And then we use a tessellation multiplier based on where the camera is as compared to the object in the world. Again, this is a bit hard to see. Let me turn off the sky sphere real quick. So let me just move out a bit. You can see the weirdness of that tessellation. Let me just speed up the zoom out. Let me just come back in, just slow down a bit. As I come back in, you can see it breaks up a bit more. There's a little bit more material that you can see. And also, this is a little bit easier to see the waves and how far apart some of them are. So that's one wave there, that's another there, there's another right there, there. You can see how close those three are to each other. So you can see the waves a bit better as well in that form. You can also see the material change a bit and more vertices get added in. They'll be more obvious in the next part of this section. So part B, or subsection B of section 4. So I'm not going to walk us through the Geisner wave formula. I'm just going to put it on the screen and go, yeah, here it is. It's pretty. I don't understand the math here, so I'm not going to walk you through it. All I'm going to say is that we adjust the normals here. And this is the speed of the waves here, and we're taking the amplitude and the height of the wave, so from base to the top peak or from base to the trough as well. And we're using that to create our little colored pattern here, which then is a visual representation of a waveform calculation. Don't ask me. I really don't understand that math. I barely understand the Wikipedia article, to be fair. For our tessellation, we move between a near tessellation. So in this case, near means how close the camera is to the surface. If I can actually do that without going through the surface, to how far from the surface it is. Sorry, you can see that the sky sphere really does affect how the water looks. So again, the lighting does play a role. Do be mindful of that, because we are going to adjust the lighting later on our island. So we control that fade between the near and far by getting the distance between the camera and the world, and then controlling that by an offset, so we can shift that distance a bit. That's what this really does. You'll see that really in the next subsection, and by how far out we want that distance to be accounted for. So the larger the number here, the farther out the farther away from 1 we're getting, the more closer to 0 we're getting, which means that the tessellation stays for longer in terms of distance from the camera. So all we're doing is getting the distance between the camera, the object, controlling for that distance, and then picking a multiplier, or lerping between 2 multipliers based on that distance. This is a very complex set of 3 videos we did, but it is actually probably the most complex material we're going to make in this entire series. Everything else, while visually may look more complex overall, is mathematically simpler and easier to conceptualize. That said, congratulations on making it through subsection A of section 4 of this tutorial series. In the next section, we will be setting up our landscape material. I look forward to seeing you in that section or subsection, and hope that you have a wonderful day.